So we're going to start looking at area of regular polygons. That's like an equilateral triangle, a square, a pentagon with all 5 sides being the same, and so on. So regular polygons, let me get one up here. Let's do a octagon. A regular polygon consists of a shape that fits inside of a circle. So I'm going to try and eyeball this, see where the center is. It fits perfectly in the center of the circle. Now I was a little bit off on guessing where my center was, but you can see what's happening. It fits perfectly inside a circle, and actually connecting this center point to these is called the radius, because it's the radius of the circle. If I do that to every point, what I'm essentially doing is I'm taking a regular polygon, in this case an octagon, and I'm splitting it into a bunch of triangles. This is really 8 triangles. Okay, each triangle has a height. Okay, on the next slide we're going to use A for that, so I'm going to use A here. Each triangle has a height, and there's 8 of them. So I have 8 triangles. That is base times height divided by 2. So that 2, let's pull that out in front and get 1/2. The A is going to stay, and we're going to use the 8 and the B together to kind of think about it in a different way. So the 8 and the B is this side here, it's also this one, this one, this one, and so on. And there's 8 of them. When you go all the way around the shape, you're actually finding the perimeter. So I could find each triangle and then multiply it by 8, or I could take that 1/2 out, take the A out, and then I could do every side all the way around, which ends up being the perimeter. 8B becomes the perimeter. Oh, ran out of room. So here's the formal definition. Area of a regular polygon is 1/2, and then I said we would use A because the word is called the apothem. The apothem is the distance from the center of a circle to the side of the shape that's inscribed inside of it. The apothem is the altitude of each one of those triangles. It is the height of each one of those triangles. It's a fancy name for when the shape is actually inside of a circle. And then perimeter we showed you because there's 8 triangles inside of an octagon. So if you do forget how to find this formula, or you forget this formula, you could find each triangle and then multiply by 8. So let's take a look at this regular polygon. We got 1, 2, 3, 4, 5, 6, 7 sides, so it's a heptagon. I don't have information about each of the triangles, but I do have enough that if that's 25, I can bring this over here and say this is 24. So there are 7 triangles because it's a heptagon, 7 sides, and I'm going to do base times height divided by 2. So 24 times 25 divided by 2 is 300, times 7 gets me 210. So that's one method. I could find each individual triangle. Or what I could do is I could use the formula 1/2 apothem times perimeter. 1/2 times the apothem, which is 25, times the perimeter, which is 7 times 24. Now if you look, essentially you're doing the exact same thing. 7 times 24 is 168, times 25 times 1/2. We also get, I forgot a 0 over here. It's supposed to be 2,100. Yeah, it's supposed to be 2,100. Sorry about that. So you get the same thing when you do them correctly. I didn't do them correctly, so I didn't get the same thing. But now we figured out the mistake. I just forgot a 0 over here. It's the same thing. Use which one works best for you. But now that we see how to use the formula, now we're going to start not giving you enough information. We're going to start making you figure out something using either 30, 60, 90 triangles or 45, 45, 90 triangles. So we're going to look at hexagons. Hexagon, what's special about each one of these triangles is this is an equilateral triangle. The apothem is 5 root 3. So I'm going to put that over here just so I know. My goal is to find that side. Well, let's find part of that side first. So our 30, 60, 90 proportion, same that it's been for a couple chapters now, is 1 over leg, square root of 3 over leg, and 2 over hypotenuse. I want to look for x, even though you could, in a way, use the hypotenuse here. You could find that radius. Let's use just the part that's on the side we actually need. 1 over x, square root of 3 over the apothem, which is 5 square root of 3. When you cross multiply, you could cancel these out as you go. You're going to get x is 5. So if x is 5, that makes this entire side 10. Since that entire side is 10, 1, 2, 3, 4, 5, 6 sides, when I do area equals 1/2 apothem times perimeter, 1/2 times the apothem times the perimeter, 10 times 6 is 60. So the area is 1/2 times 5 times 60, which gets you 150 square root of 3. So now let's take a look at a triangle. What's different about a triangle is that this is actually the equilateral triangle, meaning this angle over here is 60, and when it splits in half, that's a 30-degree angle. And when I draw my apothem straight down, up here is my 60-degree angle. So it actually flips, and you're actually looking at you're looking at the same triangle we did here, just tilted on its side. So the 60-degree one is going to be used to find my perimeter, and then the 30-degree side is going to be used to find my apothem. So I still have 1 over leg, I still have square root of 3 over leg, I still have 2 over hypotenuse. Let's call that x, let's call that y. So let's start with x. It's across from 30, so I use the first fraction, and I know the hypotenuse, so I use the third fraction. Cross multiply. So x is 6. Now let's go ahead and start the second one. I need to find y. It's across from the square root of 3. And let's go ahead and use my new one that I just found, 6. So when I cross multiply, y equals 6 square root of 3. So now if that's 6 square root of 3, this side over here is also 6 square root of 3, making each one of the sides of the actual triangle that we're looking for 12 square root of 3. And I know area is 1/2 apothem times perimeter. So the area is 1/2 times the apothem, 6, times the perimeter. And if one side is 12 square root of 3, this side's 12 square root of 3, and this side's 12 square root of 3, we get 36 square root of 3. So when I go ahead and multiply these, I do 1/2 times 6, take that result, multiply it by 36, and I get 108, and then the square root of 3 does not go away. Now let's look at a square. A square has a 90-degree angle over here, and this radius splits it in half. That's 40, that's not 45. Let's try again. Into a 45, 45, 90 triangle. Now the good part about this is these are the same. It's an isosceles right triangle, so I only have to do one proportion guaranteed. So 1 over leg equals 1 over leg equals square root of 2 over the hypotenuse. And the hypotenuse is 10 square root of 2. And that's equal to 1 over x. Cross multiply, square root of 2x equals 10 square root of 2. Cross out the square root of 2's, you get x is 10. So the apothem is 10, and since this is 10, so is this. This side then becomes 20, and this side becomes 20, and so on. At this point, I could do 1/2 apothem times perimeter. I can. I get 1/2 times the apothem, which is 10, times the perimeter, which is 20 times 4, or 80. And I get 0.5 times 10 times 80, and you get 400. Or, it's a square. Let's be honest, it's a square. Use square formula. Area equals 20 times 20, 400. When you get a square, you get to choose what you want to do. Hexagons are a little bit more difficult. You have to use apothem times perimeter. Octagons, same thing. Triangles could possibly use the height, but it might be easier based on what's given to use the apothem. So, got a hexagon this time. We're going to take our pen, we're going to find the center right about there, and I'm going to connect an altitude or an apothem. I'm also going to draw the radius because I want to visualize my triangle. I've got a 60-degree angle here and a 30-degree angle here. Since the entire side is 6, that makes this 3, that makes this 3. Because I know that side is 6, I know the perimeter is 36. I have to find the apothem. Because in my formula, I have everything except apothem. So, 1 over leg equals square root of 3 over leg equals 2 over the hypotenuse. I'm going to use 1 over leg because it's across from the 30-degree angle, and I need the one across from the 60-degree angle. When I cross multiply, x is 3 square root of 3. Now that I have that, let's start plugging something in. Area is 1/2 times the apothem, which is found at 3 root 3, times the perimeter, 36. When I go ahead and multiply that in the calculator, you get 54 square root of 3. And our last example here, we have an apothem. Find the apothem of a square with an area of 576. So let's draw a square real quick. Alright. When I go to find this, I need to find the apothem, which is that segment. Now, what's special about that, it splits this in half, but because it's a square, it's also the same. So I need to find half of a side length. So area equals side squared. 576 equals side squared. Square root of 576 is 24. So each side is 24 units long. Now since that's 24, each one of these is 12, which means the apothem is 12 also. Now I want to find the radius of that shape. Now the radius of the shape, you can look at it as the hypotenuse of this, or you could look at it as half of a diagonal. If I extend this line, it's half of the diagonal. I'm going to use the fact that it's the hypotenuse of this small triangle. It's a 45, 45, 90 triangle, so 1 over leg and 1 over leg is equal to square root of 2 over hypotenuse. 1 over 12 equals square root of 2 over, let's call it r for radius. When I cross multiply, r equals 12 square root of 2.